Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 47. Determine the moment of inertia of the shaded region shown with respect to the centroidal x-axis and establish formulas for n equals 1 and n equals 2. So let's have this region so that we can use this in future problems. So the equation of this curve is y equals kx to the n, and this is the figure. We consider the region above it. At this point, when x is b, y is h, so we consider a horizontal strip. That's the centroid. Let's also derive the coordinates, y coordinate of the centroid. So the length of the strip is x, thickness dy, and the distance of the strip from the x-axis is y. Therefore, igx, or area, equals x dy, or area is integral of x dy, or dA is x dy. So area equals integral from 0 to h, y is the variable here, 0 to h, of the area of the strip, which is x times dy. Since y is kx to the n, so extracting the nth root, so that is yg. So x therefore is y to the 1 over n over k to the 1 over n. And when x is b, y is h, so h equals k b to the n. That means k is h over b to the n. So x therefore is y to the 1 over n over h over b to the n quantity raised to 1 over n. So simplifying this is y to the 1 over n over h to the 1 over n over b. So b becomes the numerator. So x is b, y to the 1 over n over h to the 1 over n. Substitute into this equation, area equals b over h to the 1 over n integral 0 to h of y to the 1 over n dy. Integral of y to the 1 over n is y to the 1 over n plus 1 over 1 over n plus 1. So b over h to the 1 over n is y to the 1 over n plus 1 over 1 over n plus 1 from 0 to h. So we don't mind the lower limit, just the upper limit. The numerator is h to the 1 over n plus 1, or h to the 1 over n times h. The denominator is 1 plus n over n, so this n here becomes the numerator also. So area equals nb over h to the 1 over n, quantity h to the 1 over n times h over 1 plus n. Cancel out h to the 1 over n, so the area is nbh over n plus 1. Then by Varignon's theorem, or the first moment of area, area times yg equals integral of y times differential area, which is x dy. So area times yg equals integral 0 to h of y dA. nbh over n plus 1, the area, yg equals integral 0 to h of y, and dA is again b over h to the 1 over n, quantity y to the 1 over n dy. Cancel out b, so nh over n plus 1, yg equals integral of 1 over h to the 1 over n, 1 over h to the 1 over n, integral 0 to h of y times y to the 1 over n is y to the 1 plus 1 over n dy. So n over n plus 1, yg equals 1 over, so let's combine h and h to the 1 over n. It becomes h 1 plus 1 over n here, Then the integral of y to the 1 plus 1 over n is y to the 2 plus 1 over n over 2 plus 1 over n. Then 0 to h. So this is again y h to the 1 plus 1 over n times h. Let's break 2 into 1 plus 1. So n over n plus 1 yg equals n over h to the 1 plus 1 over n, h to the 1 plus 1 over n times h over 2n plus 1. So this is supposedly 2n plus 1 over n, so the n here is now in the numerator. So cancel out h to the 1 plus 1 over n. So yg is n times, cancel out n. So yg is n plus 1 h over 2n plus 1. So that's the general expression for y sub g. So that when n is 0, there's no area when n is 0. So that's why we have n is 1, which is a triangle, and it should give us 2/3 of h. So 1 plus 1 over 2 times 1 plus 1, that's 2/3 of h. Then when n is 2, it should be 3/5. 2 plus 1 is 3. 2 times 2 plus 1 is 5. So 3/5 of h. So which is true, correct for parabola. Then igx ix equals igx plus area yg square, area p square, where igx for this region, the moment of inertia with respect to the x-axis was derived in part 2, level 4 problem, I think. So you just review it, and it was nbh cubed over 3n plus 1, the formula. So ix equals igx plus area p square, where ix from level 4 is nbh cubed over 3n plus 1. So you have to review that. And you can also derive this as moment of inertia of rectangle, which is bh cubed over 3 with respect to the x-axis, minus the moment of inertia under this curve, which is bh cubed over n, I also forgot, 3n plus 1, I think. bh cubed over 3 plus n. So it was 3 plus n. bh cubed over 3 plus n. That's right. So ix is nbh cubed over 3n plus 1 from level 4 for this region. So substitute here. Area is nbh over n plus 1, and p is yg, the distance between parallel axes. So nbh cubed over 3n plus 1 equals igx plus nbh over n plus 1 times n plus 1h over 2n plus 1 quantity square. So simplifying, igx equals nbh cubed over 3n plus 1 minus nbh cubed times n plus 1 over quantity 2n plus 1 square. So simplifying by algebra, igx equals nbh cubed quantity 4n square plus 4n plus 1 after expanding this, minus nbh cubed quantity 3n square plus 4n plus 1. So 3n plus 1 times n plus 1 is this expansion here. Then all over the LCD, which is 3n plus 1 quantity 2n plus 1 square. So if we simplify, this is nbh cubed times 4n square minus nbh cubed times 3n square. So nbh cubed, sorry, n cubed bh cubed in the numerator. Then out like terms, out also like terms. So what is left in the numerator is n cubed bh cube, and in the denominator 3n plus 1, quantity 2n plus 1 square. So IGX is n cube bh cube over quantity 3n plus 1 times 2n plus 1 square. So let's check. Let's establish formulas for n equals 1 when n is 1. So it is expected triangle, therefore it is bh cube over 36. So 1 cube is 1. bh cube, 3 times 1 plus 1 is 4. Quantity 2 times 1 plus 1 is 3 square 9. 9 times 4, 36. So it's correct. For n equals 1, IGX is bh cube over 36, which is centroidal moment of inertia of a triangle. Then when n is 2, 2 cube is 8. 3 times 2, 6 plus 1, 7. This is 5 square, so 25 times 7, 175. So IGX when n is 2 is 8 bh cube over 175. And some authors have this formula for centroidal moment of inertia through the centroidal x-axis when n is 2. Level 48, determine the moment of inertia of the shaded region shown with respect to the centroidal y-axis and establish formulas for n equals 1 and n equals 2. So here, this is the same as in the preceding figure, and the area there, the area established in level 47 was nbh over n plus 1. So we consider again horizontal strip, that's a centroid, distance from x-axis yg, x-axis this time xg. So the thickness is dy, that's y. So for solution, this is x over 2, the centroid of the strip. Distance from the y-axis is half of the length, of course. So that is also xg. So area is nbh over n plus 1 from level 47. Then area times xg equals integral from 0 to h of x over 2, moment arm of the strip from the y-axis, then differential area. The differential area is the same, x times dy. So nbh over n plus 1 xg equals 1 over 2 integral of x, then differential area is x dy. Since the variable of integration is y, that's why the limits would be from 0 to h. We must express x in terms of y. So from this equation here, nbh over n plus 1 xg equals 1 over 2 or 1 half integral 0 to h x squared dy. So since x is y to the 1 over n over k to the 1 over n, and k was b over, or k is h to the 1 over n over b to the 1 over n, and that's why x becomes b over h to the 1 over n, y to the 1 over n from the preceding problem, level 47. So substitute here, nbh over n plus 1 xg equals 1 half integral 0 to h of b square, we square this, b square y to the 2 over n over h over h to the 2 over n dy. So we cancel b and combine. So we cancel b, then combine h with h to the 2, h to the 2 over n. So n over n plus 1 xg equals b, because this is b square, cancel b, over 2 h to the 2n plus 1, or 1 plus 2 to the n. Then the integral of y to the 2 over n dy is y to the 2 over n plus 1 over 2 to the n 2 over n plus 1 by power formula. So simplifying, n over n plus 1 xg equals nb over 2 h to the 1 plus 2 over n. Then let's break this and write this into h to the 2 over n plus 1, then over 2 plus n over n. Then the n here is now in the numerator, which is this. Let's break this into h to the 1 over n plus 1 times h so that we can cancel this. Actually, we can cancel this. They are like factors. So therefore, xg is cancel out, and also xg is n plus 1 times b over 2 plus n. So 1 over n plus 1, xg equals b over 2 quantity 2 plus n. So finally, xg is n plus 1 times b over 2 quantity n plus 2. So that's the value of xg. Then iy equals igy plus area p square, where p is xg, in this case, distance between the centroidal y-axis and the y-axis, so xg. And iy from level 4 for A, for B, or what's the numbering of that problem, so just review it. It is b cube h and b cube h over 3 times 3n plus 1, I think. So nb cube h over 3 quantity 3 plus n, rather. So nb cube h over 3 quantity 3 plus n. So you just look at the derivation of this formula from level 4. So substitute here. Area is nbh over n plus 1, and p is xg, actually. So nb cube h over 3 quantity 3 plus n, or n plus 3, equals igy plus nbh over n plus 1 times quantity n plus b times quantity b over 2 quantity n plus 1 square. So if we simplify this, this is nb cube h n plus 1 over 4 n plus 2 quantity square. So we can cancel n plus 1. So igy equals nb cube h over 3 quantity n plus 3 minus nb cube h n plus 1 over 4, because 2 square is 4, quantity n plus 2 quantity square. So the LCD is 12 n plus 3 quantity n plus 2 square. So igy equals nb cube h times quantity 4n square plus 16n plus 16 minus 3n square plus 12n minus quantity 3n square plus 12n plus 9. So of course 4 times the expansion of this is n square plus 4n plus 4. So n square times 4 is 4n square. 4n times 4 is 16n. Then 2 square, which is 4 times 4 is 16. Likewise, we have minus 3 times n plus 3, n plus 1 is 3 times n square. So 3n square minus quantity 3n square. N plus 3n is 4n times 3, so 12n. Then 3 times 1 is 3 times 3 is 9. So simplifying, so we have n square times n b cube h, so n cube b cube h, or nb cube h times n square. 16 minus 12 is 4, so n square plus 4n. 16 minus 9 is 7. Then the denominator is 12 n plus 3 times n plus 2 square. So igy is nb cube h quantity n square plus 4n plus 7 over 12 quantity n plus 2 square n plus 3 or n plus 3 n plus 2 square. So IGY is nb cube h quantity n square plus 4 n plus 7 over 12 quantity n plus 2 square n plus 3. So that's the formula. It's quite long. So let's check for n is 1. For n is 1, it is a triangle, moment, centroidal moment of inertia. You already know which is equal to b cube h over 36. So let's check if this gives us b cube h over 36 when n is 1. 1 plus 4 plus 7 is 12. So divided by 12, so cancel 12. 1 plus 2 is 3. 3 square is 9. 1 plus 3 is 4. 9 times 4 is 36. So it's correct. B cube h over 36 for n is 1. For n is 2, this is 2. 2 square plus 4n. 4 plus 8, 12 plus 7, 19. Then 2 over 12. So 1, 6, 19 numerator. This is 6. 2 plus 2 is 4. 4 square is 16. This is 2 plus 3, 5. 5 times 16 is 80 times 6 because this is 2 over 12. So 1, 6, 480. So therefore, for n is 2, 19 b cube h over 480. So you check for tables where n is 2. It's 19 over 480 IGY, centroidal moment of inertia with respect to the axis through the centroid parallel to the y-axis of that figure when n is 2. So that's it. Level 49, determine the moment of inertia of the shaded region shown with respect to the centroidal x and y axis. The following data apply. A is 150 mm, B 240 mm, and H 210 mm. So here is the given figure. Let's divide this into rectangle and triangle. So for solution, A is 150 mm, B is 240 mm, H is 210 mm. So we divide it into two parts, rectangle and this triangle here. This is the centroid of the rectangle, and the distance from the y-axis is half of 150, 75 mm as shown. Vertically from the x-axis, half of 210, 105 mm as shown. For the triangle, this is 240 minus 150, so 90 mm. So this is 1/3 of 90, which is 30. 30 plus 150, so 180. The distance of the centroid of triangle from the y-axis is 180 mm. Then vertically from the x-axis, 1/3 of 210 is 70 mm as shown. So therefore, the location of the centroid of the entire area would be somewhere here. And we'll call the distance from the y-axis xg, from the x-axis yg as shown. So let's compute xg and yg first. By Varignon's theorem, area equals area of rectangle plus area of triangle. So IGX equals IGX of rectangle plus IGX of triangle. Then for this IGX, centroidal moment of inertia of rectangle with respect to its centroid, let's transfer it here, as well as for the triangle, let's transfer it here. But we need XG and YG. So area is 150 by 210 plus 1/2 of 90 times 210. So for the rectangle, 150 mm by height 210. For the triangle, 1/2 of 90 by 210. So area of rectangle is 31,500 while the area of the triangle is 9,450. So the total area is 40,950 mm square. Then by Varignon's theorem, 40,950 xg equals 31,500 times 75 plus 9,450 times 180 for the triangle. Solving for xg is equal to 99.231 mm. Likewise, 40,950 yg equals 31,500 times 105 for the rectangle plus 9,450 times 70. So yg is equal to 96.923 mm. So having found xg and yg, we can now transfer the moment of inertia of rectangle centroidal x-axis to this axis here by transfer formula. So IGX of rectangle equals BH cube over 12 plus area of rectangle 31,500 times the distance between the centroidal x-axis of the rectangle and the centroidal x-axis of the entire area. So this distance here and this distance is equal to 105 mm minus yg. Again, this vertical distance, the distance between the centroidal x-axis of the rectangle and the centroidal x-axis of the entire area, IGX, here is this distance, which is 105 minus yg. So that's why we have area of rectangle quantity 105 minus yg, 96.923 quantity square. So from IG x plus area p square. This is p, the distance between the centroidal axis of the entire area and the centroidal axis of the rectangle. And the centroidal moment of inertia of a rectangle, remember, is b h cube over 12. The base is 150, the height is 210. So that's why this is the moment of inertia of the with respect to the centroid of the rectangle. So IGX of rectangle therefore is equal to 1.178 times 10 to the 8 mm to the fourth. Likewise, for the triangle, moment of inertia with respect to the centroidal axis, x-axis, is BH cube over 36 plus area of the triangle 9450 and the distance where the centroidal axis will be transferred to the centroidal axis of the entire area, which is this distance, and from the figure it is yg minus 70, so quantity square. So ig of triangle is equal to 90 to 10 cube over 36 plus area 9450 times yg, which is 96.923 minus 70, that distance there, quantity square. So IGX of triangle is equal to 3.000 times 10 to the 7 mm to the fourth. We can now compute IGX for the entire area. It is equal to 1.178 times 10 to the 8 plus 3 times 10 to the 7. So combining, IGX of the entire area is 1.478 times 10 to the 8 mm to the fourth. So as another way to check the answer, we have this IX, we can compute IX, and it is equal to IGX plus area YG square. So IGX of the entire area and the distance of the between that centroidal axis of the entire area and the x-axis is YG. So therefore, IX, moment of inertia with respect to this axis here, is equal to IGX plus area, entire area, then distance square YG square. So IX equals IGX plus area YG square, where IX is moment of inertia of rectangle and with respect to the x-axis, and moment of inertia of this triangle with respect to the x-axis. Moment of inertia of rectangle is base 150, height 210, so 150 to 110 cube over 3. Remember, this is the base. Then for the triangle, 90 times 210 cube over 12. So Ix is Ix of rectangle, which is 150 210 cube over 3 plus triangle 90 210 cube over 12 equals Igx. Then area 40,950 Yg square 96.923 square. The distance between the centroidal x-axis of the entire area and the x-axis is Yg. So that's why Yg square. So computing for Igx, it should be the same as 1.478 times 10 to the 8 mm to the 4th. Then for Igy, so it is moment of inertia with respect to the centroid of rectangle plus moment of inertia with respect to the centroid of rectangle plus area of rectangle, this distance square, plus moment of inertia of triangle with respect to the centroid here, plus area of triangle times distance square, this horizontal distance square. So Igy equals Igy of rectangle plus Igy of triangle. For that rectangle, b cube h, so 150 cube h 210 over 12 plus area of rectangle 31,500, then distance between this centroidal axis and the centroidal axis of the rectangle with respect to y. So this distance square, and this distance is equal to xg minus 75 quantity square. So Igy of rectangle equals b cube h 150 cube 210 over 12 plus area 31,500 times quantity xg minus 75. This distance between the centroidal axis of the entire area, centroidal y-axis of the entire area, and the centroidal y-axis of the rectangle. So this distance quantity square xg minus 75, this is xg, and this is minus 75 quantity square. So Igy of rectangle is 7.756 times 10 to the 7. Igy of triangle is b cube h over 36, 90 cube times 210 over 36 plus area of triangle 9,450 times the square of this distance, and this distance is 180 minus xg, this distance between centroidal y-axis of triangle and this centroidal y-axis of the entire area is 180 minus xg quantity square. So 180 minus xg quantity square. Igy of triangle therefore is 6.590 times 10 to the 7. So Igy is equal to 7.756 times 10 to the 7 plus 6.590 times 10 to the 7, and that is equal to 1.45 times 10 to the 8 mm to the 4th. Likewise, we can use Iy equals Igy plus area of the entire region xg square. Again, Iy equals Igy plus area of the entire region times xg square. We transfer the centroidal moment of inertia with the entire region, centroidal moment of inertia with respect to the y-axis to the y-axis. So the distance between them is xg. So that's why we have xg square. Now to solve for Iy, this is the y-axis is also is coincident with the h. So the formula is b cube h over 3 for the rectangle. But for the triangle, this one, we need to transfer it there. So it is b cube 90 cube h 210 over 36 because we're going to transfer it there, plus area of triangle 180 square. So 150 cube 210 over 3 for the rectangle, 90 210 cube over 90 cube 210 over 36 plus area of triangle 9450. Then transfer to the y-axis. That's why the distance is 180 square. So that is IY of these two entire region. Then equate to IGY plus area 40,950 times xg square, and xg is 99.231 quantity square. Solving for IGY, it should be the same as 1.45 times 10 to the 8 mm to the 4th. So that's a way of checking the answer.